On your USA test prep assignment last night, you had 5 free responses, and I want to talk to you about how to answer those. This is the part of the test where you're going to be typing your answers, and it says free response number 1, pair 1, pair 2, and then down below there it says 2 versions of triangles HYZ and HIJ are shown. So in other words, these are 2 different cases, 2 different versions of the same problem. Use attributes of similar triangles to determine which pair are similar. Now, they're not saying, is this similar to this? They're saying, which pair, this triangle and this triangle, or this little triangle and this triangle? Which of those pairs is similar? Justify your answer. Part B is, of the similar triangles, what is the ratio of perimeters? And then part C is, of the similar triangles, what are the ratio of areas? So I would first draw these and label them according to what it says. Like I would draw this, put all these labels on here on my paper, and then I would draw this and put all those labels on there. Then we're going to start looking at whether they're similar. Unfortunately, I can't show you both my handwriting and this, so or at least I can't right now. So let's just talk about this and try to follow along with me. You may want to pause it right here and draw it. That might make it easier for you. But they say that HY is 4, and then that YI is 4. So that means HY is 4 and HI, the whole side of the big triangle, is 8. So these sides, small triangle to big triangle, is a 4 to 8 ratio. So now let's look at HZ compared to HJ. HZ is 6, HJ is 12. So that's a 6 to 12 ratio. So this was 4 to 8. This one's 6 to 12. And this is 5 to 10. All of those are a 1 to 2 ratio. So yes, pair 1 is similar. Now let's check this. It could be that both of them are similar. 4 for HY. YI is not mentioned. Okay. HZ is 6. ZJ is 2. So this is a 6 to 8 ratio. And then this is 5 and this is 10. So 6 over 8 does not equal 5 over 10. So I would explain both of those. I would say, excuse me, let's see what to call them. Pair 1 consists of similar triangles because the ratio of each, or the ratios of smaller sides of the smaller triangles, maybe sides of the smaller triangles to sides of the larger triangle, and its triangle are all 1 to 2. You could also write that as 1 to 2. Either way. So the ratio of the sides of the smaller triangle to the larger triangle is 1 to 2. In other words, and this is where it would help to have a picture so I don't have to keep scrolling up. HY to HI, HY to HI is 4 to 8, which is 1 to 2. HZ to HJ, HZ to HJ is 6 to 12, which is 1 to 2. And YZ to IJ, YZ to IJ is 5 to 10, which is 1 to 2. Okay, now pair 2 does not consist of similar triangles because, and we said that HZ, which is 6, to HJ, which is 6 plus 2, is 6 to 8, while YZ to IJ is 5 to 10. That's part A. So let me go back here and type an A. Part B. Since the side length ratios, or ratio for pair 1 is 1 to 2, the perimeter ratio will be the same. 1 to 2. Now, you could have done that by finding the perimeters, and you could illustrate that with actually saying the perimeters. But remember that side length ratio and perimeter ratio, they're both about length. So they're going to be the same because perimeter is just a bunch of lengths added up. Now, that's as opposed to, since the side length ratio, or similarity ratio, you could say, for pair 1 is 1 to 2, the area ratio will be the square of that. In other words, for 1 to 4. Now you could use, I'm using colons, you could be using fractions for all of these. You could be saying 1 to 2 and 1 to 4. I would be consistent whichever way you want to do it, but you could use all of these, you could have been using a slash mark. Okay, so don't leave it like that. I would either both use colons or use the slash mark that means division for all of them. But either one is equally good. So this was how I would answer free response 1. Now let's look at free response 2. Given 2, 1, and 2, 4 are the coordinates of 2 vertices of a right triangle. What are 2 possibilities for the third point that results in a right triangle with side lengths 3, 4, and 5? Okay, and sketch both triangles on the grid provided. There's the grid. Okay, so first thing I would do is put those 2 points on the grid. So 2, 1, 1, 2, 1. Is it going to let me do something there? Hey, it is. There we go. And 2, 4, 2, 4. So how far are those apart? Those are 3 units apart. They're right above each other. Vertical lines and horizontal lines, you can find distance by just counting boxes. So 3 boxes. So there's a length of 3 between the 2 of those. So since 2, 1 and 2, 4 have a distance of 3 units between them, those 2 points will be the endpoints of the side with length 3. Now I need to go think about 2 possibilities. Well, let's see. A few different ways I could go with this. I could go think about how this is going to work, and I'm sorry that this is not that perfectly drawn. I could have 3 here, 4 here, and 5 here. That's one way I could do it. I could have 3 here, 4 this way, and 5. And because of the Pythagorean theorem, the 5 is automatic. If I go 3 and 4, this will automatically be 5. Because 3 squared plus 4 squared equals 5 squared. I could go 3, 4 this way, and that's 5. Or I could go 3, 4 this way, and that's 5. So I'm going to stick with this one just because that's the best triangle I've drawn so far. So here's one. So my coordinates of my third point, these 2 points, remember, were already fixed. Coordinates of my third point would be -2, 1. One option for the third point is the point -2, 1, because the distance between -2, 1, -2, 1 and 2, 1 is 4, and that makes the distance between -2, 1 and 2, 4 equal to 5. Another option, and then I would talk about one of those other options I gave you. Like, in other words, instead of going this way, it could go like this. Whoa, like that. Okay. And sketch both triangles, so I did that. It just tells me to find the possibilities. So basically, if I finish that up, I would have answered this one correctly. Now, I'm curious about this. What is this next part? There we go. It's moving on. Okay. Next free response. 2 cylinders are similar with a ratio of 1 to 2. Okay, remember that if their similarity ratio is 1 to 2, their area ratio, like surface areas, would be the square of that, and the volume ratio would be the cube of that. So let's come down and see what they want to know. The two cylinders are similar with a ratio of 1 to 2. If the volume of the smaller cylinder is blah, 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 what's the volume of the larger cylinder? Okay, since the two cylinders have a similarity ratio of 1 to 2, then their surface areas would have a ratio, or let's say, let me change that. Then the ratio of their surface areas would be 1 to 4. Now, I was going to say this even if they didn't ask me about surface areas, but notice that they do here. And the ratio, actually, let me just say, that's the similarity ratio squared. And the ratio of their volumes will be 1 to 8, which is the similarity ratio cubed. So let's go to part A. Did I hit enter? Nope, I don't know what I hit. A. If the volume of the smaller cylinder is 25 pi, I have to type the word pi, then I can write the proportion 1 over 8, that's, remember, because the ratio of the volumes is 1 to 8, equals 25 pi over x, and solve to find x, which is the volume of the larger cylinder. Try to use things like that, like larger cylinder instead of just other cylinder. Then we've got, let me solve it. So I would write that down, I would work it out, I would solve it. When I solve this, I find that the larger cylinder has a volume equal to, and that's going to be 200 pi, I believe. Part B, this is about surface area. So if the surface area of the smaller cylinder is 15 pi, then I can set up a proportion 1 over 4, because remember surface area ratio we just set up here was 1/4. 1 over 4 equals 15 pi over x, and solve for x to find the surface area of the larger cylinder. When I do that, and maybe you should say by cross multiplying so that the reader knows that you know exactly what you're doing, I will find that the larger cylinder has a surface area of 60 pi. And I'm going to stop right there. I just wanted to give you an idea of how we solve these things. I'm running out of time, so I'll stop there. If I have a chance to make another video, I might be able to do that. Otherwise, I've given you, I think, a pretty decent idea of how you want to describe your answers. It's kind of like doing a free response problem or a performance final, just you're typing it. So if this is the last thing you see before you take the EOC, guys, you are ready. You are ready. You're going to kill this test. Just remember that you know these things. Take the time to think about what you know and how you can use it for a problem. Don't panic. Use your time wisely, and you will do great on this exam. See you later.